In this sublesson, we are going to see an overview of ACI, Cisco's application-centric infrastructure. Before getting into the details of ACI, let's take a step back and look into what is the current demands of our next-generation data center. The industry is currently focusing on an intent-based data center. An intent-based data center is an SDN-enabled data center that provides services to the applications so that the network functions the way it is intended to. In other words, that means you only need to express an intent to get certain things done with the data center, and the data center converts that intent into services. The intent-based data center, or the next-generation data center, has the capability of intelligent automation and assurance, centralized provisioning system through which you can define the policies or the services from a centralized location, and the network is automatically provisioned for those services or applications. The network operators also demand for simplification and the application agility. That means the focus is not on the network, but the focus is on serving the application. To overcome the needs of the intent-based data center, Cisco has provided a three-set solution, which is through ACI, NAE, the Network Assurance Engine, and Tetration. Cisco ACI, or the application infrastructure, provides optimization and automation, network security and availability, multi-cloud networking, and it also helps with translation and activation of the services. The NAE, or Network Assurance Engine, helps predict the impact of the changes in the network. It also helps to verify network-wide behavior and help assure network security policy and compliance. The NAE also helps with proactive assurance. That means it helps you identify if there is going to be any failures. Tetration. Tetration provides application dependency mapping. That means it is helping with network performance monitoring and diagnostic. The tetration also helps with real-time visibility and insights into the network and helps with workload security. The tetration is Cisco's solution to reactive assurance. In this sublesson, we are going to focus on Cisco's application-centric infrastructure. One of the questions that often arises when discussing about SDN or application-centric infrastructure is, why do we really need SDN? The reason behind the need for SDN is that the networks are complex. There are a lot of components and devices coming into play when defining the policies for the applications. The second part is the networks are the last silo to experience major shift. That means the network should remain the same, whereas it should be able to serve the application and its requirements. Application-centric infrastructure, or ACI, is Cisco's solution to software-defined networking-enabled data center. With ACI, the paradigm has changed from network-centric to application-centric. That means the developers now have to focus only on developing the application, and the network is already present to serve those application requirements. The ACI fabric has two main parts. First, the APIC controller. It's a centralized controller that is required, or that is the data center's unified network policy management system. And then you have the physical layer, which is, or physical fabric, which is comprised of leaf and the spine switches. The APIC controller is connected to the leaf nodes, and the leaf nodes are then connected to the spine nodes within the fabric. Let's talk a bit more about the APIC controller. The APIC controller is the policy enforcement engine of the ACI fabric. It focuses on application and abstracts the network functionality from the end user. The ACI doesn't perform decoupling of the control plane and the data plane. The decoupling is happening with the management plane. The management is all done by the APIC controller, and the leaf and spine behaves what the policy has been defined on the controller. The controllers can be made part of clusters for high availability. So you can have a cluster of 2 or 3 APIC controllers which are running in a cluster. If one of the members goes down, the other 2 members are there to serve the fabric. And even if all the nodes go down, the ACI fabric will still keep up and running. The fabric is not really dependent, or the fabric is not in functional mode only when the APIC controller is up and running. Once the policy has been defined by the APIC controller and pushed onto the ACI fabric, that is the leaf and the spine, then the leaf and spine functions independent of the APIC controller. The APIC controller also performs the following tasks. It performs the configuration management, defines and manages policies for the fabric, and helps with layer 4 to layer 7 service integration in the ACI fabric. The ACI fabric also helps with the APIC controller also allows the integration with third-party hypervisors and VM orchestrators such as VMware ESXi or even Microsoft Azure. The ACI physical fabric. The ACI physical fabric, as mentioned before, comprised of leaf and spine nodes. The ACI fabric links are routed links and are configured as IPN numbered. That means on a given leaf node or spine node, all the links are having the same IP. Within the fabric, the underlay is running ISIS. The ISIS is used in fabric to advertise the loopback and perform or provide VTIP reachability. The fabric uses pervasive or anycast gateways at the leaf layer. That means you have gateways for the host for each, on each individual leaf. All the traffic in the ACI fabric is sent with extended VXLAN encapsulation. That means the data plane is extended VXLAN encapsulated. This actually helps the ACI fabric to decouple the identity, that is the endpoints, from the VTEPs. The endpoint information within the ACI fabric is exchanged using MPBGP. So we are running MPBGP to exchange the information regarding the host or the endpoints connected to the leaves. In the next sublesson, we'll see a bit more about the components of the ACI fabric.